Sige, Jamie. Good morning, guys. So I hope my session here can tie all most of the prior sessions together. I'm talking from the context of a system administrator, somebody that manages a data center. So imagine that you have about 10 million incidents a day to examine in your log files. You have a syslog. Your network already has antivirus, malware detection tools, and you have syslog servers. So now, what is the next challenge for people like us doing system administration? I would say that the answer is time. How many people would we need to hire to go over 12 million records? And how many people do we need to hire to generate some insights about those 12 million records into something that management can understand? So the other challenge also is to create visualizations. And of course, on top of that, you have a manager that does not provide you with the budget. So if you wanted to buy high-end solutions, your manager will most likely say, maybe next year. So now here comes the question, why R? Can we have some sort of interaction? How many of you have heard or are using R right now? R.
Heard of it.
You've heard of it, Department of Finance. Who else? Jason, have you heard of R before? It's a precursor to, it's a sequel to S. So S is a statistical package. And so after S, so R has roots in statistical analysis. How many of you have heard of Python? Alright, so I'm talking to the other camp. So we belong to the R camp. In the machine learning and AI world, there are two programming tools that you can use, Python and R. So the things that we're using here in R can be easily crafted in Python. Alright? So why R? Number one, it's free. It's powerful. What else? It can ingest a lot of input formats, JSON, CSV, Excel. It can do even screenscaping. It can even connect to your Google Store and Google BigQuery. And the other thing about this is you can also output your insights and your results, not only in the standard console, you can output it as a web page, as a JPEG, as a PDF, as we will later on show. So at this point, are there questions among the crowd? Are we okay? So here are some security scenarios that, if we have time, we'll go through all of them. We'll go first with one of the challenges that we face in the modern malware-infected world. Quick question, who among you are from Trend Micro or who among you do malware analysis regularly? Isaac, do you do malware analysis? Who else really does the antivirus, the deep dive stuff in malware? I need a fact checker to correct me if I'm wrong. Guys, you're so quiet. Oh, who? A name, please. Who? Joey. Okay, Joey, please correct me if I'm wrong. So we'll just go and go straight to the malware. So, correct me if I'm wrong, initially when the first generations of malware came out, it was easy to block because they had hard-coded IP addresses for the infected PCs to connect to a command and control center. So all you have to do is find out what the IP address is, block it on your network, and you neutralize all the infected PCs. If they can't connect to your command and control, they can't deliver a payload, right? But then the malware authors got really creative. So now they don't do IP hard coding. What did they do next, Isaac? Or Joey, what did they do next how did they move forward? So they use DNS, right? So now they're not using IP, they're using DNS. But then, system administrators also quickly figured out, if you're using DNS, I can just put in a DNS domain in my DNS server and route it to a null device. So again, that doesn't work, right? So the third iteration is what they call DGA. So Joey, DGA, am I correct? It's domain generating algorithm. Correct, okay. So how does it work? So instead of hard coding the DNS in the malware will have an algorithm based on time where if it's today, it will have a different domain. Tomorrow, it will query a different domain, right? So it's hard for you to keep on creating null entries for 100 DNS domains. Practically not possible. So, in this section, we'll show you a piece of our code that was done by this really great guy called Jay Jacobs. He created the book for data-driven security. So one of the dead giveaway of malware-infected PCs is that suddenly you see a lot of DGA-created DNS queries on your DNS logs, correct? So once one of your PCs are infected, it will start doing DNS queries, and you will see a lot of DGAs. So am I making sense, maybe, so far? Alright? Okay. So the detection should be based on the number of DNS requests that have, and these are white papers, and I was told by Christopher Ellison yesterday that he was part of the paper that did this. So there's a white paper on how to do machine learning, and this is how they did it. They look for the number of the domains with low dictionary word matches, 1. Number 2, they look for low ratio of vowel to consonants. So that your DGAs would probably have like XYZ, but little of the A, E, I, O, U. Alright? And here another paper said that, the DGAs will have a lot of NX errors. So because they're made up, these domain queries will typically result in error. Domain is not existent, non-existent domain. So this is the high-level overview before we go to the actual demo. And so, our goal is to be able to detect when a malware infection starts in our network, and then once it starts, try to determine what is the valid DGA to block. Alright, that's our goal. So, the way we will do that is to find the source IPs with the highest NX errors. And then once we know what the source IPs are, we look up the source IP NS request with no errors, right? The ones without the errors are the valid command and control servers. And then, of course, we block them. Now, let me see if I can get my R coming up. Does it show up? No. Let me see it here. Okay. Let me do this. So, this is an R notebook. Our notebook runs on top of R. R is the console. Before our notebook, you would only get this console at the bottom here. This guy. You type in your commands there and the results come up. So don't be intimidated. The nice thing about R is, number one, it is reproducible. So once somebody creates a script, you only need to know how to run it. Right? So how do you run the script? So the nice thing about this is you can also pepper your R script with documentation so that even years later you can remember why you did or why it was coded this way. So these are my notes. If I wanted to see where I based the study off, okay. My thanks to Eric and John for helping out. So, how do you run an R script? So this is the actual script. The ones that are enclosed by the 3 apostrophe and then the R. And at the bottom is this guy. That signals the end of the script. Teka lang ha, let me see if I can change my... Change the screen resolution from duplicate to... Okay. Help? Who knows how to set it? I'm having a hard time doing the 2 things. Okay? 2, 5. Okay, so the script is done. I will just go through a little bit so that you can maybe get a bit of an idea. So this is the proof of concept. Now, like in a C program, you typically include libraries, right? So R is also set up like that. You can include the library, and these are the libraries that we are using. DGA. So DGA is the DGA detecting algorithm created by Jacobs. So we didn't create this, we just imported the library. So we will run it by just clicking it here. So it's running. So as a proof of concept, we gave it some test account. So Facebook, Google, Sign Up, Twitter, Yandex, MSN.com. These are the good ones. And then for the bad ones are things like this. Sample domain generated algorithm. And then here's the test. Right? So when we run it, this is the result over here. Can you guys see it from all over there? So the system will come back and say Facebook is a legit domain with a probability of 100%. And it can come back to you and say, okay, this guy is probably a DGA. So it's a classification, it's what we call a classification algorithm in machine learning, right? Any questions so far? It's a bit technical, but all you have to remember is that you can take home the script, plug in your DNS log files, and it will do the classifications for you. Okay, and then this is the test. And then these are the results. So it will say how many are probably legit and how many are probably DGA. So that is the proof of concept. Now we will go through an actual DNS log. So this is the actual DNS log file. The command to read is just using read CSV. I could have hard-coded the file, but I wanted to show you that should your DNS system be creating a new DNS log file every day, you do not need to hard-code. You can do file choose, and then it will pop up file browser, and then you just choose your current DNS to run. And then head will display the first 5 records of the table. Alright, so let's run it. You don't see it because it's on my other screen. So it will pop this up. You choose this guy. So this is the actual DNS log. So this is the file. These are the first 5 records. And if you wanted to see the other fields, there you go. So remember, this is about 80,000 DNS logs. Now, here comes the meat. We will now use the DGA predict function to add a column to that previous table. So here's the beauty of R. You can go here and double click there, and you can see the table, right? So this is the table. These are no error, NX domain error. Okay, so that is DNS. And here, so we now have the table, but we are just going to use the library made by Jay to put in a label. This record is probably DGA, or this record is probably legit. It saves you the time of having to manually, using an intern or a junior techie, to manually score each one. Right? The library will put in a tag. So let's run it. So this is actual. But don't worry, the other ones, we will show you PDF. It's already generated. Okay. I should also mention something. There's a command called filter. Because we only are looking for DNS in the direction of send with NX record, we can then filter it by this one, where the direction is equal to send and the status is NX domain. That cuts down the table. So here, original DNS is 8,440 observations. By the time we filter them, we're now looking at 1,788. Okay, so that's DNS2 table. So this is the second table. And this is what you have. Even at this stage, it's still not usable for upper management. Right? It still doesn't tell us who is the source of the infected DNS. Right? So now we go through this one. We find the proportion of IPs accessing legit versus non-legit domains. And so we use this library called tidyverse. This is a bit complicated. We open DNS, then we pipe it to group operation where we group by source IP and the predicted value. Then we pipe it to a summary operator, which will summarize it by count. And then save all of those in a new table called DNS4. Alright? So let's see what happens. So now, from those 8,440 DNS log entries for, I think that was about 2 hours worth of DNS log, we now have one IP over here. One single IP that was accessing 1,486 predicted DGA. The probability is very high that this guy is the guy that's infected inside your network. Right? Agreed? And we did not have to examine the records one at a time. We can give this script to your junior level sysadmin and just click play, play, play. Boom. Alright. But wait, there's more. Okay? That alone, your manager will say, okay, so what? Well, we could then hand it off to Accenture. They can, because we've narrowed it down to a single IP, they can go in and do the stuff they did yesterday to find out how it was infected and all the other stuff. So now that we have an idea of which IP is infected, we can go back and now we will try to see which is the valid command and control DNS so that we can plug it, right? So again, we will tell our junior sysadmin to just click on play. And so, let me try to explain. So, because we know that this is the IP that's infected, we now filter the record to only all the DNS queries by this guy. And we pass it to a clean, and then the clean domain function, okay. We use a library called CURL. So those in the Python world will also know what CURL does, which is to resolve the DNS to an IP, right? So, well, if you are not familiar, you just have to take my word for it. When you run it, the domains that are generated, it will convert that into an IP. So, did I run this? Have I run this before? Okay, let me run it again. This one is pretty fast. Now, after running it, we will distill it into actionable insights. Okay, something wrong. Okay, here. The scripts here could have been run using one thing. I broke it down into separate modules so that we can examine it step by step. Right? We could have done it one single step and at the end of the hello.
So it's like good contradiction, sir.
I came prepared.
Ayun, very substitution, sir. Yeah, very interactive. If we want it that way.
Okay. Okay, pala yun.
And then, while nag-shot si Sir, parang si Sir Wilson.
Si Sir Wilson Conde.
Alright, let's give him a round of applause. Announcement po, since tinatagin lang natin. Buhay na pala yung CTF. I mean, the CTF for PodCrowd is already working. So it has been deployed, right? So, can you give them the details?
The PodCrowd CTF is live now. You can play for the PodCrowd CTF in the playing room near the main CTF. Spot.
So, for the price for the PodCrowd CTF, that's $1,500. And if you want me to translate it, it's a lot of money. Alright, that's the simplest explanation for it. And then there's $1,500, a grand, and $250.
So the price for the first place for PodCrowd CTF is $1,500 US dollars. Then the second place is $1,000 US dollar. Third place is $500. The fourth place is $250 US dollar. So yeah, you can play now. Just find us in the CTF area. Yeah, just give me a heads up. So I'm wearing red by the way.
Well, alright, let's give a round of applause to Sir Wilson once more.
Thank you. So remember I said that R can save your output into different formats. So here I save that same R into a PDF, which comes in handy in cases where your script suddenly fails and you have to show people that this is going to be the result of that failed script. It's going to say that your private IP 172.16.05 is sending a lot of DGA domains that are resolving to 64.70.19.03, of which 5 are known to be DGA and 1 is probably legit. So, if you were still waiting for your malware provider to come up with a signature for this particular attack, in the meantime, you could neutralize it right away by just flapping this IP. Right? And again, you don't need to study R. Once the script is there, you can just click on play. That's the beauty of R. Right? So, we go back to okay. That's the demo. Next. So I crowdsourced the topics that I should talk about. And one of the other things that is cool is to how you can use machine learning to identify advanced persistent level threats, right? Assuming you're not a client of Pandora and Web Ranger, right? Okay, so advanced persistent threat detection are identified as these are the type of attacks that are just, one a day, one or two a day. Not something that will raise particular alarm, but they happen every day until they hit something, right? So the way I would think about it would be to do a histogram. You have your data, you create a histogram, and you look at a graph of which IPs only show up once a day. Hits your network once a day. So you may need to have some wrapping, you may need to wrap your head around the graph because the one that I encircled actually shows that you have a lot of IPs hitting your network once a day. That's the highest number of lines. So the Y label is the number of IPs that we see hitting our network once a day, right? Next that we will show in the same demo is data exfiltration attempts. So like if you were the Department of Finance or you were BDO and Jason Street suddenly was able to enter into your network, the next thing they probably would do is to suck out all your data, right? But if you have a junior CSAT running our script every hour on the hour, I would show you how you can detect all of this right away. So here for data exfiltration attempts, we are looking for traffic that is sending out a lot of data, super loud. The source of the IP is internal because it's exfiltration, and the destination is external. So it's very logical, right? So here, this is the other end of the spectrum of the histogram, right? You're more worried about this guy, that guy. That guy, that little bump just says that there are few IPs, but those few IPs are sending out 4 gigabytes of data. That's what it says. Alright? Yesterday, Christian Ellison also talked about IoT and the attacks. So, using R, you can program it to filter out, summarize, aggregate, and display all the attacks that are targeting port 23, whose source is external. He's targeting internal IPs, and get this, we can use R to merge external data sets. Like in our example, we will use Alien Vault. They have a free-to-use public IP reputation data set. So if you see somebody hitting your port 23 and they're listed as a known bad guy, chances are that's an attack. Alright? So the other one is brute force. So these guys will target your dark IP, much like what Jason was saying before. You set up false targets. Once they hit it, you set up alerts. So you know right away. So in your network, let's say in Globe, not all of your IP are activated. There will be some IP blocks that are still not being used. Alright? So once some traffic and hit starts hitting those sequentially, you know people are already scanning you. Right? Or they would be attempting to connect to block ports. Those are dead giveaways. Okay, and of course the source is external. Right? Let me see now. Okay, we go to the demo. So we're finished with this one. We're finished with that one. Let me close that. Don't say we don't need that one. So now here's the script that I guarantee if you run every day you'll be able to catch a lot of attacks in your network. Okay, so again, here are the libraries that we need, so we run it. It will load the needed libraries. And then this is the one that takes a long time. So we have an Elasticsearch system running on Graylab. Raymond Nunez is running Kibana, so it's about the same thing. Now here is something that is, normally you would use this, read CSV file, choose. But this one is a slow process. The better one is to convert the file into read RDS so it reads faster, right? But even if it reads faster, it still takes quite a bit of time. This is an actual extract of a one-day log of our network containing, sorry, it's not 120 million records, 12 million records. I checked the digits last night. 12 million records. Imagine hiring somebody to go over it manually. Can you do this in Excel? Quick question. Can you do the things here in Excel? Who says yes and who says no? Excel is, surprisingly a tool of choice for other professionals. Who says yes?
Yes.
Yes. Who says no? Joseph, you know why you cannot use it in Excel? 12 billion records.
No. That's the latest.
The limit for Excel is
1 million?
1 million.
No, they updated that.
I use the Office 365, it's still 1 million. So, okay.
They updated that.
So, okay, going back, I think the log file is now, let me show you what the log file does. So, boom. So, this is 12 million records, and this is the table that it read. Okay. Song and dance before everything goes down. You guys are so quiet. Am I not connecting with you on some level? Joey, do something. Are we okay? Okay, alright. It's big. It's big. Let me tell you, it's big. So, yeah. So, you, of course, can scroll down and wait some more. You can also scroll left. And those are all the sample records. Obviously, we're not showing all the fields that we're monitoring, just in case one of you tries this on your own. Alright, so now that we've loaded the table, here are some commands that you can run to see what the table is all about. So it gives you the structure. So that's the structure command. This is the structure of your table. You can also run a summary command, which will show you, very importantly, mean distribution. Like you have a field, a numeric field called bytes. It will show you the minimum value, the first quartile, the mean, median, mode, and the third quartile, and the max. So it gives you an idea of the range of values in your table. So, that's just for the R in us. Now here, head, as I said before, shows you X number of records. In this case, we wanted to show you the first 10 records. So this is what the records would look like. Now here's the command to create the histogram. And again, we just tell our junior assistant to just click on that one. It will go in, run, and then come back with a nice graph. Not yet the graph. This just, okay. This is some ETL, extract, transform, load. We are taking out some records that are incomplete. We don't want to analyze incomplete data. So here, complete cases only. After we analyze this, so trust me when I tell you that when I click this one, this is the result. So that we save time, right? So here, this one shows the number of IPs hitting your network that are seen only once in that data log. So when I tell you that your network looks like this, it means a lot of people are accessing your network only one time. One time. Then now, we can also, again, this one is based on the count, not the byte. Just on the count, how many times? We are not even talking about how big the data file was, just the count, right? So I have to separate the histogram into the lower end and the upper end. Because if I didn't do that, the scale would then hide this one. This guy would be almost impossible to see, right? When you have a big graph and you lock everything in, this small guy over here would be invisible. You would never see it because it's so scaled down. So that's the reason why we separated the histogram into the lower end and the higher end. Then once we have them, we arrange them by descending order. Looks like SQL, right? So those of you that know SQL, if you use this as a template, you know how to modify it to suit your needs. So these are all the IPs that shows the chattiest IPs in my network. So the first one was based on count. Now we want to see based on bytes, based on load of data. So if you run it, this is what you will see. Right? So although we have a ton of people hitting our networks one time, in terms of bytes, they don't show up in our syslog MRTG files. The normal ones are in the middle. This is normal. Now also for the higher end of the histogram, there is that guy. So why is that guy important? Exfiltration. The moment you see somebody at the extreme of that histogram, somebody is sucking out your data. Alright, so now that we know that there is a prima facie evidence of some wrongdoing going on, we drill down. So we did this R script. So we now arrange the data by descending traffic and then we need the top 20. So essentially that's what it says. So once we run it, this is the effect. This guy sent me 50 what? How? 57 million? Yeah. 1, 2,
57 na.
57 million worth of content, length, bytes of data. This guy, he did it with 360 sessions, right? So if I were able to, and this is a good justification for your boss to study R. You know, boss, if I were able to block this guy out, then our bandwidth, which is expensive in the Philippines, can go down a bit for the legal traffic to go in. We save money by being more secure, right? Any questions so far? Questions, comments, share. Those of you that do R, So where am I now? Okay. So now that we know the IP, typically, Betty, what would you now do? Once you have the IP, you go to who is. Who is this IP, right? But then imagine, I'm lazy, so I tell my staff, I don't want to do it, you do it. But then my staff says, but I have a ton of work to do. So we automate it using R. And this is where I asked one of my friends, who's the R guru of the Philippines. Whenever I need something done in R and I don't have the time to do it, I knock on his generous heart. Please help me with this one. So he developed this routine. Even IP, it will come back with the AS number and everything, automated. So the external data that we're using is MaxMind. It's freely downloadable. Given an IP, it will give you the AS number and the organization name. So all you have to do is run Joseph's routine. So this is the routine, movie. And at the end, what can we now do? What can we now do at the end? So these are the phases. Yeah. Now we have an AS number that goes with that IP. And once we have the AS, we can now aggregate, sort based on AS number. And guess what? We can now group and tally by organization without having to go to who is. And this is the nice graph. And this graph is done by Gigi Platt, contributed by Hadley Wickham, one of the favorite of the guru of R. And your staff doesn't need to have graphics capability. The command is this one, Gigi Platt. So count the organization and then we order them by count, give you the top 20 and then pipe the output to Gigi Platt, which will use then the org and the number to display a bar graph using identity and then label the top as organization and use the thing black and white and then flip the coordinates. So that's the command. And this is what you get. So who's the biggest source of traffic for our network? PLDT. Followed by Comcast, Time Warner, AT&T, T-Mobile. So, that's nice to have. But then, there's more. Once you know the AS number, AS9299, we can now drill down. Who among AS9299 is the biggest contributor of traffic to our network? So again, there's this command, you run it, this is the result, these are the IP all belonging to our favorite friend, the LPP. Alright? So these are the traffic counts. And because we also monitor by country, we can also break down the traffic. Nice to know, nice for reporting for your big bosses by country. And if you wanted to do an MRTG like, when did the attack take place? You can do a activity graph using box plot. And that's another interpretation. Okay, now here. Are there bots or attackers visiting my website? This is where we use reputation scores from Alien Bot. I think, Isaac, do you have a similar available database? Not yet, okay. So assuming Isaac from Pandora has that service, we can download their data, which is a reputation score. Given this IP is probably bad, or this IP is probably good. Now the question here is why? Why do we need to have a reputation score? Remember the large histogram with the large number of single visits? That's a large number. By hand, how can we filter out who is actually attacking us? Into investigation to IPs that we find listed in the alien vault as being suspicious. So this is actually what we did. So we just eliminated some of the false positive. And scroll down. Detect automatic persistent. So here, look, filter, count, for two, merge, IP, flow, head. So these are all the IPs that are hitting our network just once every day. Once every day. Typically, the hacker mentality says, if I hit your network once every day, I will probably get away with it. Not if you're running R on a daily basis. You'll see the IP and it will flag it for you. Let's scroll down to where it shows it. Okay. Can't find it anymore. Wait. Maybe you do this. Yeah. Alright? So again. Okay. Without meshing with an external data. So what we are saying is, a lot of people are visiting you. Most of them are probably good guys, but you need to examine each one of them. But you don't have the time to investigate everyone. So who's going to get priority of your time? The way to do that is to marry it with a reputation engine. So these are the IP, these are the traffic count. They are all one, right? But then, if you scroll to the left of the table, here are the results. This is malicious. This listed in my IPN. So these are the people that you block right away. Advanced persistent threat. Without knowing malware signatures. Because I'm thinking like there's this gap between a 0 day and the time thread or all those antivirus company can release the signature. What do you do in that gap? You do this. Now, yesterday also we talked about, do you guys want to see the DNS and NTP? No, skip. So, this is just a template. If you wanted to know everybody attacking your DNS for DNS amplification or NTP, network time protocol amplification, this is the code. You just say that, okay, remove the 8.8.8, which is known Google DNS. So that's a false positive. Remove it. And I want all the results where the destination port is 123, which is NTP, or 53, which is DNS. So you filter them and you will get this nice result. Now, most of these are source IP. You will see source IP coming from our internal network. So probably this is an open DNS. That, you know how much bandwidth you can save if you plug your DNS relay? Like I had a 15 meg of bandwidth, fully used up. But when I plug the DNS amplification, it dropped to 8 meg. That alone. Okay. So this one, I think all of my friends in Facebook, you saw one of my posts 3 years or 4 years ago. I'm seeing a lot of attacks on port 23. I don't understand this. Port 23 is, an old protocol. And then a few months later, I start looking at, I start getting feedback that people were actually trying to hit your IoT, your CCTV, your DVR camera. That's why they're hitting 23. And these are all the people in that network that is attacking our port 23. Now, remember in my slide, other ways to detect brute force by, dark IPs and dark port. So there, you just tell your system, the script, to filter out all access to your dark IPs, and you will be left with people that are most likely brute forcing your network. Right? Okay, so nakaka-bore ba ako sa inyo?
No.
Ha? Good. Encourage me naman. Oh, yes! Now, this one is a demo of Showdown was introduced to me by Raymond Nunes, who's having a forensic session out there, and Sir John Patrick Lita, right? So, who does not know of Showdown? Jason, you don't know what Showdown is? Isaac, can you help me out? What is Showdown? So Showdown is like the Google that documents all your network and all the vulnerabilities. So instead of doing it one at a time, you can use R to automate it. Why would you want to do that? In our case, we want to automate periodic checking of Showdown to see which among my internal IPs in my data center are listed there. Right? So you are one step ahead. So in case you are interested, the method here was first shared by, do I have time? What's my time? 10 minutes na lang. Or over laptops. 10 minutes. So remember, when you use ARM, you can export it as either a web page, a PDF, a JPEG. So in my case, I exported it as PDF. This is something you can show your boss. So here we're loading, okay, here. We say we want to create a table of all IIS servers running in the Philippines. So this is how you put it. Showdown search. IIS country : Philippines. Right? Okay. So if you wanted to search for IIS server in the US, what do you change? Country : US. Right? So, and then you call it. And then you call it, and it will come back and say there are 10,221 servers. How many in the first page? 100. What else does it know about these servers? Here. We know the transport, we know the version of the IIS. As you know, IIS has a lot of versions from 5, 6, 8.5, 7. We're looking for other version 5 IIS because these are most likely unpatched and very vulnerable, right? So what else do we know about them? Okay. Now here is the cool thing. Now once you have the data, you can visualize the data into a map. And this is the command and this is the map. By version, right? And what does it mean? What does your junior technical assistant need to do to run this, to create this? He just needs to know how to click the play button. That's it. Right? So because you can use this, so you get the idea, I know, that although creating the R script may need significant investment, once R scripts are done, you don't need the rocket to be a rocket scientist to use the R script on your network. Right? It's like script kiddies. They don't really need to be elite hackers to take down your network. They just need that script.
Yeah.
So, on the other side, as system administrators, we just need our script to protect our network. Right? So, I guess I'm about at the end of my 10 minutes. Credits. So these are the people that help us deliver this sharing session to you guys. Joseph Tabadero, our guru. He's a PhD in math, currently teaching in UP Baguio. Who else? Eric Riata for helping me with gathering DGA samples. Raymond Nunez and John Patrick Lita for help with Showdown and Census.io. And if you want to take this further and share and build on top of it, these are the two books I would recommend. This is the guy I was telling about, Jay Jacobs. This is his book, Data-Driven Security. And the other guy is Hadley Wickham. Very well known in the art community. He's the one that created the ggplot, IDverse, everything. Right? And so now, a bit of plugging for a personal advocacy. As you know, Philippine internet is very slow, and one of the reasons why it's slow is because nobody knows the actual measure. So we came out with a community project where everybody downloads a measurement app, measures it using the GPS of your phone, and we accumulate all the results into a server, and we now know who is better in a certain area. And I think if I can get Yuri to volunteer his services, help us secure it. Is the mobile app, can the mobile app be corrupted to send false data? Right? And this is me, and that's the end of my presentation. Thank you.